SpaceX's revolutionary approach to spacecraft heat shields represents a pivotal moment in aerospace engineering, one that has the potential to redefine how humanity ventures into space. For decades, the intense heat of atmospheric reentry, reaching a blistering 3,000 degrees Fahrenheit, has been a formidable challenge for engineers. Historically, the solution has been ceramic tiles, trusted for their lightweight and heat-resistant properties. These tiles protected iconic spacecraft like the Space Shuttle, establishing themselves as a cornerstone of thermal protection technology. Yet Elon Musk and his SpaceX team saw an opportunity to innovate beyond the limits of ceramics, proposing a radical shift to a metallic heat shield. This bold move, which has sent ripples through the aerospace community, isn't just a change in materials. It's a transformative step toward creating spacecraft that are faster, tougher, and more cost-effective. The implications of this transition are monumental. Ceramic tiles, though effective, are notoriously delicate and labor-intensive to maintain. A single mission can result in hundreds of damaged or dislodged tiles, requiring painstaking inspections and replacements. This has traditionally led to extended turnaround times between flights, slowing down progress in reusable spacecraft technology. By abandoning ceramics in favor of stainless steel, SpaceX aims to overcome these limitations. Their new system promises spacecraft capable of enduring multiple reentry cycles with minimal refurbishment, dramatically increasing efficiency and reducing costs. Moreover, this innovation aligns perfectly with SpaceX's ambitious vision of interplanetary exploration. Robust heat shields are a critical requirement for missions to Mars, where atmospheric conditions during landing and reentry pose unique thermal challenges. A reusable spacecraft with a resilient metallic heat shield could become a cornerstone of sustained human exploration of the Red Planet. The genesis of SpaceX's heat shield revolution can be traced to a quiet Texas morning in 2021, when Starship prototype S-20 prepared for a landmark test. With its gleaming, black half-shell design, the prototype represented a departure from the traditional aesthetics of spacecraft. However, its design was more than cosmetic. It was a gamble, an embodiment of SpaceX's willingness to challenge the status quo. For decades, ceramic tiles had been considered the pinnacle of thermal protection. Engineers relied on them because they were lightweight, heat-resistant, and extensively tested. Yet, during SpaceX's early test flights, the tiles revealed a critical flaw. They weren't sufficiently durable. High-speed cameras during Flight 3 captured the dramatic failure of dozens of ceramic tiles, which broke free and spun away as the spacecraft breached the sound barrier. The scene was haunting and sobering, forcing engineers to confront the limitations of a technology that had long been regarded as untouchable. The failures didn't stop there. Flight 4 brought the team to a breaking point when Sarah Chun, a lead thermal engineer, noticed alarming telemetry data. Temperatures around Starship's flaps, critical components for controlled landings, were spiking beyond acceptable limits. These control surfaces were being exposed to extreme heat that the ceramic tiles simply couldn't withstand. Chun later described the heat pattern spreading across the surface as wildfire, signaling an urgent need for a completely new approach. Faced with mounting challenges, Musk proposed what many considered an unthinkable solution: abandoning ceramic tiles altogether and replacing them with stainless steel. Initially met with skepticism and even laughter, Musk's idea quickly gained traction as the team explored its potential. The shift wasn't just about swapping materials. It was about reimagining how spacecraft could survive the harsh realities of space travel. The weeks that followed were a frenzy of innovation at SpaceX's metallurgy lab. Engineers tested various steel alloys under conditions designed to mimic the extreme heat and pressure of atmospheric reentry. They weren't just looking for a metal that could survive these conditions. They needed one that could do so repeatedly and with minimal wear. The breakthrough came from Dr. James Rodriguez, a veteran materials scientist whose work in nuclear reactor cooling systems provided the perfect inspiration. Rodriguez proposed the concept of a transpirational cooling system, where thousands of microscopic channels within the steel tiles would allow coolant to flow through, dissipating heat as it built up. This design wasn't just innovative. It was revolutionary, combining the durability of stainless steel with active cooling to create a system capable of enduring the rigors of space travel. The real test came during Flight 6, when SpaceX integrated over 2,000 experimental metallic tiles into the Starship prototype. Each tile was equipped with sensors to gather data during re-entry. As Starship hit the atmosphere, temperatures soared beyond 3,000 degrees Fahrenheit, and the control room was tense with anticipation. The results were mixed but promising. The steel tiles survived the re-entry process, marking a major milestone. While they emerged discolored and slightly warped, their survival demonstrated the potential of the transpirational cooling system. This was a victory that validated SpaceX's bold decision to move away from traditional ceramics. The implications of this innovation extend far beyond the realm of aerospace engineering. SpaceX's shift to metallic heat shields represents a broader philosophy of challenging conventions and embracing bold risks to achieve groundbreaking results. The use of stainless steel, a material more commonly associated with kitchen appliances than spacecraft, underscores the importance of thinking outside the box. This approach not only reduces costs but also accelerates the timeline for reusable spacecraft, bringing humanity closer to a future where interplanetary travel is routine. In the grand scheme of space exploration, SpaceX's heat shield revolution is a step toward a new era of resilient, reusable spacecraft. By combining the durability of stainless steel with the ingenuity of transpirational cooling, SpaceX is paving the way for missions that can withstand the most extreme conditions. Whether it's frequent launches to low Earth orbit or ambitious missions to Mars, this innovation has the potential to make Starship the most robust spacecraft ever built. It's not just a technological leap. It's a testament to the power of rethinking what's possible in the pursuit of exploring the final frontier. High-resolution cameras captured a striking phenomenon during SpaceX's testing phases: a rippling effect across the surface of the metallic tiles, resembling waves frozen in metal. This observation led to a groundbreaking realization. The tiles needed to function as an interconnected system rather than as individual components. Meanwhile, in SpaceX's propulsion lab, another team tackled the equally daunting challenge of the cooling system. Traditional coolants were quickly ruled out due to their weight and complexity, prompting engineers to propose a radical idea: using Starship's own liquid methane fuel as a coolant. Already stored at cryogenic temperatures for propulsion, this fuel could serve double duty. However, the engineering challenges were immense. The coolant flow had to be precisely calibrated. Too much would waste precious fuel, while too little could lead to catastrophic overheating. Through countless iterations and even a dramatic incident where a prototype tile melted through its test stand, the team pushed forward, undeterred by setbacks. By early 2024, the heat shield project had evolved into an intricate and sophisticated design. The latest iteration featured a honeycomb structure beneath each tile, optimizing coolant distribution while maintaining structural integrity. Simulations showed that this system could withstand not only Earth's re-entry conditions, but also the even harsher environment of Mars' atmospheric entry. The implications extended far beyond thermal protection. Unlike traditional ceramic tiles that required painstaking inspections and frequent replacements, the metallic system was engineered for rapid turnaround. In theory, a Starship could land, undergo minimal inspection, and be ready for another launch within hours instead of weeks, revolutionizing spacecraft maintenance and reusability. As testing continued, each prototype revealed new insights. Ship 35, in particular, became a testament to SpaceX's perseverance. During one pivotal test, engineers subjected a full-scale section of the heat shield to conditions more extreme than actual re-entry. The material glowed white-hot, reaching temperatures exceeding 3,500 degrees Fahrenheit. Observers watched, clad in protective gear, as the metal appeared to dance between solid and liquid states, yet somehow maintained its structural integrity. This incredible display reinforced the urgency of perfecting the metallic heat shield as SpaceX's Mars ambitions crystallized. Establishing a permanent presence on Mars would require a heat shield capable of surviving multiple entries through Earth's and Mars's vastly different atmospheres. The math was clear. Traditional ceramic technology couldn't meet these demands. The metallic system, with its active cooling and robust construction, represented humanity's best hope for turning interplanetary travel into reality. As SpaceX prepared for an ambitious 2025 schedule featuring 25 planned flights, the heat shield faced its most rigorous tests yet. Each launch would challenge not only the metallic system, but also the broader concept of rapid reusability. Success could mark the transition of space travel from an expensive frontier to humanity's next great adventure. Recent footage from these tests revealed the remarkable progress being made. In controlled environments, engineers subjected test articles to extreme conditions, watching as the materials glowed, deformed, and occasionally failed spectacularly. Each failure, however, provided invaluable data. Teams analyzed every detail, from microscopic stress patterns to thermal distribution across tile surfaces. Despite continuing to use ceramic tiles in some prototypes, like Ship 35, insiders knew this wasn't a sign of hesitation. Instead, it was a methodical approach, gathering critical data while perfecting the metallic alternative. The transition to the metallic heat shield is expected to coincide with another historic milestone, the first successful catch of a returning Starship. The next few months will be critical as SpaceX continues its relentless push toward a future where space travel becomes as routine as air travel. The metallic heat shield isn't just about surviving re-entry. It's about redefining the boundaries of space exploration. It embodies SpaceX's philosophy of making the impossible not only possible but also practical. This innovative system represents a pivotal moment in aerospace engineering. It's not merely about replacing ceramic tiles. It's about reimagining the very fundamentals of space travel. Through countless tests, failures, and breakthroughs, SpaceX has demonstrated that bold solutions are often the most effective. The success of this new heat shield system could transform space exploration from an occasional feat into a routine occurrence. With each Starship flight, humanity edges closer to a future where Mars missions are commonplace and life on multiple planets becomes achievable. This isn't innovation for its own sake. It's a practical, reliable solution designed to carry humanity to the stars. Humanity's journey to the stars is poised to take a monumental leap forward. As we look ahead to the ambitious 2025 flight schedule, we will witness whether this revolutionary approach to thermal protection will redefine spacecraft design for generations to come. The transition from ceramic to metallic heat shields symbolizes the spirit of progress driving space exploration, paving the way for humanity's most daring goal yet, Mars settlement. In the 20th century, landing on the moon was humanity's greatest technological triumph. Today, the challenge is even greater, establishing the first human settlement on Mars. This dream is becoming reality through groundbreaking partnerships between leading space organizations, with plans to launch as early as the 2030s. Mars, located 250 million miles away, beckons humanity to undertake a 6 to 9-month journey that will test both human endurance and ingenuity. But reaching the red planet is only the beginning. The true challenge lies in building a sustainable human presence on this alien world. Starship, the most advanced spacecraft ever designed, will serve as the cornerstone of this historic mission. This isn't just another space endeavor. It's humanity's first step toward becoming a multiplanetary civilization. As international competition intensifies, space programs around the world race to reach Mars. Yet, Starship stands alone, uniquely engineered for this monumental task. It represents a crucial advantage in humanity's bold venture to extend its presence beyond Earth. This journey to Mars gained an unexpected boost with a groundbreaking discovery during routine scans of the Martian surface. Satellites detected vast underground caverns near the planned landing sites, a discovery that could revolutionize colonization efforts. These natural formations offer critical protection against radiation and extreme temperatures, making them an ideal foundation for sustainable living on Mars. The discovery of these caverns marks the dawn of a new era in space exploration. The first phase of the Mars mission begins under the crimson dawn of a Martian morning. As the initial unmanned Starship breaks free from Earth's atmosphere, millions of people around the world watch in awe. This mission carries more than just equipment. It carries the collective hopes and dreams of humanity. Robotic pioneers face their first major challenge shortly after landing, when a fierce dust storm threatens to overwhelm their solar panels. In a dramatic display of artificial intelligence, the machines deploy innovative dust-repelling force fields, a technology that would later save countless lives during colony operations. Once on the Martian surface, robotic explorers begin breaking ground. Beneath the surface, they make a stunning discovery: underground ice deposits that are far more extensive than previously imagined. These deposits contain traces of ancient organic compounds, guaranteeing water, security for future colonists, and raising tantalizing questions about Mars's past. Could these deposits have once harbored life? The Redwater drilling system proves its worth by uncovering a network of natural tunnels formed by ancient water flows. These tunnels become integral to the colony's design, serving as ready-made conduits for power lines and water distribution. However, working in these subterranean passages presents unique challenges, from structural stability to maintaining safety in low-gravity conditions. As the project evolves, the selection of the first human crew captures the world's attention. These pioneers represent humanity's boldest venture yet, embarking on a journey that will not only explore the unknown, but also redefine what it means to be human. The discoveries made during the initial robotic missions provide a solid foundation for the crew's work. The ice deposits, underground caverns, and natural tunnels promise not just survival, but the beginnings of a thriving human presence on Mars. With each step forward, humanity inches closer to transforming the red planet into a second home, fulfilling our destiny to become a multiplanetary species. This is not just about exploration. It's about ensuring the survival and evolution of humanity in the vast expanse of space.